Okay, hi guys. I'm Michael, and this is the Intro to Git workshop. So, kind of going over what we're going to learn today. So, four main things that or like four main sections, I guess, of this workshop. So, the first thing I'm going to do is just kind of briefly go over Git, use some demonstrations, some pictures to kind of explain what Git is and how it works. Then, the second part is literally just going to be a bunch of commands that you can use, or basically how you interact with your repository. And then the third part is not on this PowerPoint. Actually, I'm going to pull up a terminal and kind of just demonstrate how I would go about using Git on a project and yeah, just doing some examples. And then finally, extensions, how can Git be applied to your projects? And really, I'm going to be talking about what GitHub is and what like remote repositories are. Okay, so kind of getting into it. Before we start, um, I am going to use Git. So if you want to follow along, you should probably install it. So installing it is pretty simple, I think. If you go to this website, someone can copy it into chat. That'd be nice. Git-scm.com/downloads. It'll have a bunch of downloads. And actually, it'll tell you how to download it if you don't have a Windows system. For Windows, it's just simply installing it using installer. Mac, you can use Homebrew or you can download. I think there's an executable too. And then Linux, if you use Linux, you probably know how to install things and you probably have Git installed by default. Um, and so, yeah. As I talk to the first section, you guys can install it. um, and then, okay, well, I was planning on using VS Code, but I don't think I will anymore. VS Code is nice because if you look on the side, essentially it shows you what changes you've made, what changes you've staged. I'll explain that later. And then you can really easily just make a commit through there. So here are the instructions. Again, it's on the VS Code website. So if you just search up download VS Code on Google, you'll find a ton of instructions. Okay, so now actually getting into the workshop, what is Git? So without Git, right? Okay, imagine, well, I guess think back to like elementary school when you're like making projects. I guess projects weren't that complicated, but especially for like digital art, I'd say, and like video editing, things like that. Sometimes things tend to you like make a change and then you don't want to keep that change, right? You want to go back a version. A good example of like version control is Google Docs. Google Docs literally tracks every single change. So like if someone like messed up your document, you can just go back to a certain version. And so without Git, this is actually something I had. Essentially, you literally just create versions of it. And I actually did this because, sometimes these files would corrupt. Um, and so by doing this, I basically saved versions of it. But if you just look at this, it's really hard to tell um, what is in each version, like what changes between each version. Like you literally have to open up each one to see the differences. If you look at this, I don't know why it's not sorted. Oh, because I spelled it wrong. But it's really hard to um, figure out like where everything is. Like literally, it's just 0, 1, 2, 3, 4. Um, yeah, and so this is super inefficient. And also, imagine each one of these is like a gigabyte. Well, they're not that big, but they're definitely projects I've gone gigabytes over. If you have a bunch of files, like that just multiplies the storage space. And so this is bad. And of course, you don't really use version control for like photography and stuff like that. But especially for code, you don't want to make copies of your code file. That's like really inefficient. And so with version control, um, I'll ex- I don't know if I'll explain this, but this is actually this is on GitHub, but Git essentially what it does is it tracks changes, right? So originally it was like this, and then after your edit, it looks like this now. And it shows like things you've added. It also shows things you've removed. So I think Git really simplifies things. Everything is in the same place. And also, you don't have to make copies of files because there's actually a special folder that Git makes that will save all of these changes. Okay. Uh, so yeah, so kind of the formal definition of Git is a distributed version control system, and it's actually made by the same guy who made Linux, Linus Torvald. I don't know how to pronounce his name, but yeah, essentially why distributed, right? So all these cases I've been talking about, especially with like the file management, is local, so on your computer, right? So let's say you have a file and you make a change to it, you can save that change on your computer. But let's say you have two people who are working on the same project. How do we like share changes? Like, do I or like I mean, I remember I've done this before in middle school where literally we had like this drawing that we were working on together. And so literally one person would draw something and then we'd upload it onto Google Drive and the other person would download it and then edit it. And we go back and forth. And so that's really inefficient. And so what Git does is essentially it gives you actually, I'll kind of go more in depth into this in a later section, just because of the distribution part. But it allows many people to have copies of the same history, right? So everyone has a copy of the file history, and when someone makes a commit or makes a change, then everyone else can essentially take that history and like merge it into their own history. And so it's really nice for collaboration. But before I get to collaboration, we need to go over really what is Git and some of like the keywords that Git goes over. So every so imagine like a folder or a directory. Um, Git will treat that as kind of a project, right? So the word Git uses is a repository. Um, and so inside the repository, those are all the files that you're working with, and all the ones that it wants to track. So I've been using the word commit and changes kind of loosely, but formally defined, a commit is essentially a set of changes that you want to say, okay, I want to save this point in history. And then in case you need to come back to it later or look at it later, you can go back to this commit. And every commit is represented by a really long string of hashes, but you can also add a message to it, which I'll explain how to do when we actually make commits and stuff. Um, and then another really cool thing about Git, and actually what makes Git stand out against other version controls, because Git isn't the only one, it's just the most popular. What makes Git stand out are its branches. And so imagine if someone wanted to make actually I'll show you the branches in a actually really nice diagram later, but let's say one person wanted to change one file and someone else wanted to change another part of that file. If they're working on different things, then why not split it into two branches, and then at the very end they can come back together and merge it together. um, and then again, this is explained later, but staging and committing are they sound like the same thing, but essentially staging is kind of so you make changes and then you stage them and then you commit them. And I'll show you later what that means. And then finally, when you initiate a Git repository, it actually doesn't know what it wants to track. So you have to tell Git to track the files that you want it to track. Um, So, okay, a visual demonstration. So kind of before getting into like the actual nitty-gritty command line stuff, I'll just show you visually what Git actually does. So here's a box with triangles on top. It doesn't represent anything. But let's say this is your project, right? Um, so now I'm going to add some changes to it. So I'm going to add some eyes, add a mouth, and then remove these bottom edges. And so Okay, well, so let's just say for argument's sake, we're tracking this already. Um, and so Git is like, okay, so I see you've made these changes and I'll actually go and detect that for you. And then you're like, okay, cool, I made those changes. Now I want to save or commit those changes. And so then notice how nothing actually changes between staging and like the non-staging area. But staging essentially is like a second layer where you can look at all of the files that you want to commit, and it's just kind of like a confirmation thing. Um, and then we make the commit. And so now if you go back, so I've highlighted all of these in different colors just to show you things I've added and removed. So then once you actually make the commit, it'll put it into the file history and it will create a commit. And so this is like kind of an object. Um, and Git will essentially store this commit. Um, and then when I make new changes, right? So let's say I want to add whiskers too. The commit is still here. So all of the stuff is stored in the same history. Meanwhile, like this is in the new history. So again, after I finish editing this, then we go back again, we stage it, and then we commit it. So that's kind of how Git works. Next. Okay, so now I'll explain branching briefly because it's a little complicated. Um, but okay, so um, now instead of like the loose commit model, let's imagine your history, right? History flows on a line. And so this first line is your master branch. So actually, it's called main now. They're kind of changing the name, but it's your master and main branch. Um, and so if you go back, remember this commit that we made? It's actually committed onto the main branch. And so if you think about it, it's just like imagine a really long timeline, and you're essentially adding a bunch of changes every single time. Um, and so when you make a commit, it actually like creates a history, right? So um, if you just look at master, it's pretty simple, right? So we make a commit and then we make another commit, and essentially you're just adding onto the timeline. But let's say we branch off, and in this case, I named it Whisker. But essentially, this branch, let's say I'm a developer and I want to add whiskers to this cat. Well, I guess not to cat. Um, and so I create a different branch and then I make the commit, right? Making all the changes. And then what I do is I merge it back into the master branch. Um, and so if you look at it, it's pretty simple with just one branch, right? You essentially take all the commits that have been added to master, um, you make changes, and then you put it back onto master. If nothing's changed in master, you don't have to worry, right? Because you're the only commit. And it will actually create a merge commit. Now, this isn't backwards order from latest to, or from most recent to least recent. But yeah. So why is branching useful? Because this just seems like, why don't we just make this commit on the master branch? Or yeah. Um, However, what if we want to add more things? So let's say I want to add a neck to the cat too, right? But or okay, let's say I'm adding a whisker, but then someone else decides, hey, I want to add a neck. And adding whiskers takes a long time. I don't know why. Um, but or yeah. So, or let's say we have the same idea on the same day, right? So we both make a branch. Of course, these don't conflict because they're like different branches. But notice how they branch off of the same point. And so each one of these will essentially receive a copy of this. Um, and then now they make their respective changes. So now notice how um, these are different, right? This one has whiskers, but this one has a neck. And then let's say the whisker person, who's me, finishes first. And so the whisker person merges their commits back. Um, and now this is on like the main timeline. Um, and so as we move forward, now the person who made the neck decides, oh, look, we're done, right? So then they merge it back. But now there's an issue, or there might be an issue, because this cat doesn't have whiskers, right? And so Git is actually really smart as it will manage this internally, and it'll see that hey, this one made changes to this part of the face, but this one made changes to this part of the face, and so if they didn't change like the same part of the face, then it'll automatically create a merge commit and it'll actually merge the two changes together. And so it does this with code, obviously, not with actual cats. Um, and so let's say the neck person actually like changed the whisker part of the face. When you make a merge commit, it'll actually get mad at you. And it'll say the changes are at the same place. And then it'll take you through like how you resolve the edits or the merge conflicts. And I'll demonstrate that later too. Um, oh wait, this is wrong. Oops. um, but yeah. Um, so having branches is useful when you have multiple people working on it. And this will actually kind of go into how to work with other people in remote repositories, which I'll explain later. Okay, so usage. Now I've kind of given you diagrams, shown you how the Git workflow goes. So now this is just going to be a list of commands. So don't try to memorize it. I'll demonstrate it and like say them over and over. But these are the main commands that are used. There are a ton of other commands like subcommands that are like that do fancy things. I'm just gonna go through the basics for now. So Git init. Oh yeah, and their descriptions. You can read them either now or on your own time. But Git init basically says, okay, I want this to be a Git repository because not every folder in your computer can be a Git repository, or that would be really big. So of course you have to declare it. Say, this is a Git repository. I want to track changes on here. And so simply just type Git init in any folder, and it will create a subfolder. Actually, if you show hidden files, you can see the docket folder. But yeah, next is staging. So I kind of went over staging, but essentially staging is just like uh, I have all of my changes ready to be committed, and that's kind of like a, are you sure you want to commit this? And so you do that with git add. Essentially, you're adding files to the staging area. And so you can do git add a file name, or I'll show you how to add like every file. And you can actually add like folders too. So like if you want to add all of the files in one folder, you just git add the folder name. Okay, and then finally we have git commit, right? So now we've made changes, we've staged them, and then now we are committing. So as the description says, it's like a snapshot, right? So it's a point in history where all the changes that you made is stored in commit. And then, yeah, so you can just type git commit and it will actually like give you a prompt to type a message in. Or you can actually type the message in the same command. And if you've done any like Linux development, you probably know how to do that. Yeah. So this will actually commit anything that's on the staging area, right? So actually, here's a good example of why we use staging. So like, let's say I made some changes, but I only want to commit a certain part. Because like, let's say I made changes to 2 files, but only one of them is done. And so I only stage one of the files. And so then when I commit, it'll only save the changes in the file that's done. Um, and then I can keep working on the other file without it being tracked by Git or without it being committed into this commit. Okay, so some other helpful functions, some other helpful commands. Git status. You'll see me type this a lot. And this essentially tells you what every single one of your files are doing, right? Is it being edited? Is it tracked? Is it untracked? Is it in the staging area? Things like that. And I'll show you that. And then Git Log will essentially show you a timeline of all of your commits from the latest commit all the way to when you first created the repository. Yes, and it will show a commit hash, the message, and some other data. And then how do you like create branches and how do you manage your branches using the git branch command? And I'll show you all the subcommands of that later. And then finally, you have Git Check Out, which is kind of a strange word to use if you've never done any version control, but checking out uh, is the same thing as changing branches, right? So um, you can use this to jump between branches. And then finally, we have Git Merge. And so how do we merge our like new branch back to the main branch? Well, use merge. And so yeah, Cool. So that's pretty much, well, actually, I have one more section about remote repositories, but I'm gonna go over to, can you see the new screen? I'm gonna go over to a terminal and actually just like demonstrate how I would navigate through Git. So first thing you want to do is you want to create a folder or a directory. I'm gonna just name this Git workshop. Doesn't really matter what you call it. Git doesn't really care what you call it. So right now I have nothing in it, right? So what's the first thing I do? We use git init. And so it'll initialize an empty repository. And so notice how it says empty, initialize empty Git repository and blah, blah, blah. And actually, if I look and I list all hidden files, you'll see that it creates a .git folder. And so this folder will contain all the changes. So then let me make a file, right? So let's make a README, right? A lot of projects have this. This will be Git workshop. I'll just put title for now. So now Git status. I type status and you can see it'll tell you a bunch of things. So I'll say on branch master, right? So we're on the master branch, no commits yet. And then untracked files. So what I was talking about tracking or files that it tracks. So the first time you create a file, it actually doesn't track it. So you have to put it in the staging and then it'll automatically track it then. So again, reading, it actually has like very nice output. So it says untracked files use git add the file to include what will be committed. So now I will git add readme.md. So now if we type git status, now it says changes to be committed, new file. And so now it says, okay, you've staged these. And so now you see it's green, right? So if I make a new file, let me just test.txt. Oh yeah, the echo command just writes, or using the 2 arrows, just writes the output of this to that. So now if I do git status, notice how it shows that I have README staged, but then text.txt unstaged, right? Or not even tracked. So if I do, so I'm gonna make a commit. And so now, in theory, text.txt shouldn't be committed, but README should. So I do the commit and it'll pull up this thing, right? It says, please enter commit message for your change. So I'm just gonna do initial commit. And you can change this, I'm pretty sure, the default text editor. But now I've made a change and you can see, so essentially it says master, and it'll actually give me a commit hash. So this is the hash I was talking about. Initial commit, one file change, one insertion, and this create mode essentially is saying, okay, now we're going to track it, and it creates like a history file. So now if I go to git status, um, slow. Nothing. Okay, there we go. Sorry. So now if I type in git status, it will show that nothing added to commit, but untracked files present, right? And so it's basically said we committed this, and now only text.txt is still untracked. Let's add text.txt because it's feeling kind of left out. Commit. So now that menu is kind of annoying because every time I have to open it and then save it and then close it. So instead, what you can do is you can use a command line option. Oops. So if you do -m, that's basically saying git commit and then a message, right? So you can just type your message in here. So added text file. Added text file. So notice how I wrapped it in quotation marks, and that's because I have spaces. Um, so then it'll treat that as like a string or one message. So if I commit it, notice how it says it's on master, and then here is the commit hash. Here's the actual message. Again, one file changed, one insertion, and it'll create a history for that. So this output is nice. I can see the recent commit I just made, but what if I want to see like 3 commits back or something? That's where the git log command comes in. And so now it spits out a bunch of information, but it's not as complicated as it looks, right? So again, here's the full hash of the commit, right? This basically, there are so many characters in here. Essentially, it's hexadecimal, so 0 through 9, A to F for every single one of these. So that makes, I don't know how many combinations, but none of these will overlap. So you don't have to worry about that. It'll list out the author, the date that was committed, and it'll actually show my time zone, which is currently Central Daylight Savings Time. And then it'll have the message here. And so this is a really nice way to see all of your commits, right? And it'll go from the most recent to the oldest. And if you look right here, this is pretty interesting. So it says head is pointing to master. And so if you think about it in a different way, you can think about how it's a linked list. I don't know if you've learned that, but essentially, you have the head. The head is a pointer, right? And so it points to this first commit. And then this first commit points to the second commit, or the commit before that. And it'll just be a long list of pointers pointing to each other. Um, and so head is basically where we currently are in history. And you can time travel. I won't go over like how to jump in time. That's a little complicated and you probably won't need to do that. But yeah, head is essentially where we are right now. So now we've shown how you commit, how you stage things, doing git status and doing git log. So if I list out my files, we have readme, we have text.txt. So readme contains just that. And then the text file contains just test, right? So let's say I want to edit text. Text.txt. So yeah, here's Vim. Oops. So let's say I just want to write hello world, right? So now this file contains 3 lines instead of the original one. So now if I type git status, it'll say, hey, look. Notice how it doesn't say untracked files. Now it just says changes not staged for commit. So now we're actively tracking this file. And Git will essentially say git add, use git add to update what we committed. And then actually, this is a very interesting thing, right? So let's say you made a bunch of gross changes that you didn't want to keep. And actually, I will actually show this right now. So if I cat is actually the command that I use to print things out. So now the file or right now the file contents is test, or when I committed, it was only test, right? And then I added a space and a hello world. So now I'm going to use this git check out, minus text.txt. And notice how I did say that checkout was used to change branches. It's more than just to use to change branches, just like this case. But mainly it's used to change branches, I think. So again, I'll tell you. So let's say I want to discard the changes of text.txt. So I do that. It doesn't actually give me a message, which I guess is a good thing. Now, if I do the same cat.text.txt, notice how it only says test now, right? The hello world is gone. And that's because I got rid of those changes. Um, so let me add that back because I'm feeling sad now. Except now it's hello cat. Um, so if I do git add text.txt, git status, again, now it says changes to be committed. And notice how earlier it says new file. Now it says modified. And so essentially now it's saying, okay, we've modified it. And I've kind of been ignoring this line, but git reset head file. And so you can essentially um, unstage things by using that command. Um, that's a little in depth on exactly what it does internally, but yeah, I'll tell you how to reset it. So let's commit it -m, remember to, what was it? to write a message and then added a cat. So now if I go to Git Log, now we see we've added a cat, we've added a text file, and here's our initial commit. So it goes backwards in history. And you can actually see that with the times that we've committed. So now let me change both files, right? So let's say I want to edit this. Oops. This is a text file. And then I'm also going to edit README. Really cool workshop hosted by, I can't spell, hosted by me. So now use git status. Now it's just 2 files. And it's like, hey, you should stage both of these. And so this is interesting because we could do git add readme.md and git add text.txt, right? But let's say you've changed like 20 files, or you've changed a ton of random files, right? And you don't want to do that really. So a better way to do that is you can do git add. So remember how I said you can add folders? Well, you can actually just add dot. So dot is a reference to like the current folder. So it'll add basically everything inside of this folder. Another alternative is -a, I think. And that's basically all. They do the same thing. Now you have to be careful because let's say make directory test folder. So let's say I'm in the test folder, right? If I do git add dot, it'll add everything in the test folder, which currently is nothing. So if you type git status, it'll say, hey, you haven't added it. And actually, you can see, it tells you the dot means the parent directory, right? So it wants you to do git add dot readme. But essentially, by doing git add dot in like a subfolder, it only adds the stuff in that folder. So okay, I'll demonstrate git add -a. So doing -a essentially just does git add dot in the root folder, and I'll add everything. So again, if I go to git status, now it says changes to be committed, these files, and then use git reset head to unstage. So these are all the same. And then I can do git commit -m more fixes. All right, so then I git log that, and we see, boom, it adds it on top. And so now it's time to be lazy and not even go through the staging. So yeah, readme.md. So let's say I don't want to like go to git add and then git commit. Let's say I just want to do that all in one step. Generally, I would suggest you don't do it all in one step just to check. But git is cool. But if you want to do it all in one step, you could do git commit. So before we had the -m with the message, git or more messages, but of course, there's a bunch of options, but a really useful one is -a. So -a will essentially stage all the changes of the files that Git is tracking, and then it'll make the commit. Now, notice how I said it'll stage all the changes in the file that Git is actually tracking, because it won't actually stage files that aren't tracked. And so that's kind of a caveat with this -a. But actually, before I do that, if I do git status, again, just to check. It says modified README. Notice how it's not staged. So I do git commit -a-m, more messages. Now it says, um, or now the commit works. Oh, I guess I didn't show you. Hold on. Let's say I make a change, and I do git commit -m made change. Git will get mad at me because it just says no changes added to the commit because nothing is staged, right? And so by doing -a-m, it'll stage it before it commits it. And so that's just like a shortcut to use. Okay, that's all the main ones. Oh, I actually didn't write this out. Um, but I guess I'll demonstrate it live. So one of the, or let's say I didn't want to make all those changes that I already made, right? Let's say, well, what is it more fixes? Um, let's say I didn't want to like add those random messages. So we're we're here, right? And then this is the initial commit. So if you think back to my example with Google Docs, right? Let's say you want to go back 2 versions and restore the entire project to look like this, or the entire repository to look at this. What you do is you do git restore. So the git restore command will essentially, it won't delete. All right, so the important thing to note is it won't delete these commits. These will still be here. In fact, it'll just add a new commit with all of this content, right? That's important because you want to see all the history. Do git restore. It's not git restore. I'm git. Uh, what was it? Git. It's not restore. It's yeah, git revert. Oops. So yeah, the command is git revert, and it'll revert all the changes, which I guess kind of makes sense. So then, of course, I'll say could not revert, but that's not a bad thing. So again, when you don't know what's happening, look at git status, right? So, well, that's a lot of things. But it's okay, yeah. So currently reverting, not staged for commit. So there's a lot of things to unpack here. Oh, oops. Okay, so this first one, this is me forgetting to commit before. Notice how I had something uncommitted, and then I did all of this. So ignoring this, I can just do git add readme, and that's fine. But this is the important one, right? So unmerged paths, it says both modified, and so essentially what it's saying is your current commit, so right now we're on this commit, has modified that file, or since the commit you want to revert to, that file has been modified. So both this and this has different text.txt files. So if I look at text.txt, um, you'll notice some interesting new things have appeared, right? So head is currently where we are, like I guess the master branch where we are right now. And so this is what's present in head. And then this line essentially is saying everything on top is in head and everything on bottom is in this commit. Um, and so there's nothing there because we didn't have anything there. And I'll show you an example after this where I actually have 2 things um, intersecting and I'll get mad. So what we need to do to merge, okay, so this is essentially a merge because we're merging that past history with our current history. And so we just need to essentially manually delete what we've added, but Git will essentially tell us where it is. So it says, okay, between these 2 lines, there's this new thing. So you need to get rid of it. So I'm just gonna get rid of it. And then git. So now we gotta get status it should say, now it should say modified. It's green because we've actually fixed it. Um, and notice I kind of ignored this first line the first time, but once I've resolved those conflicts, you don't actually have to commit it. It says fix conflicts and return and run git revert continue. Um, so it'll actually tell you that you're currently doing something. Continue. And then it gives me an error. Why? Oh, oops. We do have to, I forgot. So you have to add it. Of course, you have to stage it still. And so now it's happy. Everything is changes to be committed. Oh, wait, just kidding. It's right here. It's still here. Um, yeah, so now if I git revert continue, now, okay, yeah, I could have added a message too. But now it's like, okay, we finished resolving everything. And these are the hashtags are comments. So this is like the actual message, and it'll give you a default message. So you can just keep that. And then boom. So if I do git log now, this is very, very interesting. It'll create a new commit, right? This is not the same as this one. Notice how like the hashes are different, but it'll say it reverts a commit. And so that's how you go back in history essentially. However, notice how these new things are still here. So if we wanted to get the state of this back, we could revert again to this version. And so yeah, the revert is useful. Yeah, it's very useful. If you made like a big change and then you want to go back a version or multiple versions even. Okay, it's 46. So I'm going to spend like 10 minutes on branching, just really quickly. So now I'm going to introduce kind of a new command, Git Branch. So if you just type Git Branch, it'll show you one thing. And you're like, what is that? Why is there a star next to it? Well, it makes more sense when we make a new branch. So let's like make a branch. So how do you make a branch? You just type Git branch and then a new branch. Let's say we want to add description. Actually, that's too long. Add DSC. So now if we type Git branch again, now look, our new branch that we just created is here. And so essentially the Git branch command will list out all of your branches. And then, well, this is nice. It'll highlight the current branch you are in green and it will put a star next to it. So now remember that command that I explained a while ago, Git Check Out. We can actually change branches. Add the description. So now we do Git branch. Oops. And now look, the stars moved and we're on the add description branch, and it says switch branch to add description. And if we type git log, you'll notice how it says our head, which is currently what all of our commands will be working on, is pointed to add description. And master is here. So why they list both of them is because we're on the same commit. So now we're going to do some changes in this new commit, or in this. So let's add a description. This is a test file. Wow. So I'm gonna save it. Git status. So now, I've kind of been ignoring this line as well, but now it tells me that I'm on a new branch. And so what if I check out back to master, right? Will it keep the change there or will it not? It's a good question. And actually it won't contain those changes in that branch because again, all you've done is change the files, you haven't actually committed it. And so you haven't committed it to any branch. So now it's just like a floating change, right? And I'll tell you, you've modified text.txt. And so if I do git status, you see changes not state, or it looks the exact same, except it'll say we're on branch master. So let's just check out back to add description. And then again, it tells us text is modified. Just a little warning, let me switch branches. Git status. Again, we're on a branch, right? I mean, before we were on the master branch. So all of the other commands to make a commit are the same. So let's just go through add commit -m added a description to the text file. Then we do git log, and here's where branching comes in. So now it's like, hey, master is actually behind the commit from add description. And if I get, and okay, yeah, here's where kind of jumping between branches can get confusing. So right now we're on the add description branch, so we can see that it is ahead of master. If I git check out back to master and I do git log, notice how you can't actually see the new branch. Um, because it's now ahead of master. And so now master has no idea what's happened to it. And it's kind of on its own, right? It's ahead of master, it's had its own changes, so it's on its own branch. It's kind of the key thing about branching. So actually, let's create another branch and see what happens when we mess things up too much. Um, so okay, yeah, and another thing, right? Remember how I combined staging and committing into one command? Well, you can also combine checking out and creating that branch that you want to check out to in the same command. This is actually through Git check out -b. So the -b is saying create a new branch. Um, so let's just say Bob fixes stuff. Let's say you have a coworker who just comes in and decides, hey, I want to fix things. Without realizing that I'm already changing text.txt. Oh, actually, um, you kind of want to check Git status. So tell you what branch you're on, nothing to commit, working tree clean, which is good because that means you don't have any like random edits floating around. Oops. Also, I'm using Vim, this text editor. So let's say Bob was here because he's not that helpful. So Git status. Right, we've modified text.txt. So git commit -a-m. Remember -a. Oh, okay, it actually says it right here. You can use git commit -a to add everything. And so our message, Bob is helpful. So now type git log. Right, so in this log, notice how our earlier add description to text file commit is not here. Instead, Bob's commit goes right after the master commit. There's actually really important to note because these are this is what we call diverging history, right? Because you've taken one point in history and now split it, and so now we have two separate histories. So now we want to combine them together, right? Let's say Bob's changes aren't that good, and so he gets done with them really quick. Oh wait, and then one more thing, we do git log on master. You can only see this added account, right? So now we have this disaster unfolding. Not really, but we have two different branches, and now we want to merge them. Well, obviously they're not going to be merged at the exact same time. So let's say Bob merges it first. That's the git merge command. And so what git merge does is it will merge all branches commit onto the current branch. And currently we are on master. So I want to merge Bob. I forgot what it was called. Git merge Bob fixes stuff. So it says a lot of things, but it'll say updating. So update up to the last commit Bob made. Fast forward. I don't fully know what this is, but it's just like a way for it to merge. And so if it doesn't need to like fix any errors, I'll just fast forward the merge. It'll show you what has been merged. This is the same thing it shows when it commits. And I'll say one file change to insertion. So now we do git log. And so, yeah, and so here is the commit that Bob made. And so now we've merged that, right? But This is the ideal scenario, right? When you're only having one. But let's say, let's say I come back, right, and saying, okay, I'm done with my thing. I've checked it. I've proofreaded it. Now, now I want to merge my branch. This is where problems arise. Auto merging, at least it's trying. It says conflict. Merge conflict, automatic merge failed, fix conflicts, and commit the results. So again, going back to Git status, you have unmerged paths. So that means we're in the middle of a merge, fix conflicts, and run git commit. What are the unmerged paths? Well, text.txt. So if I go into there, you'll notice how these little arrow things are very familiar, right? Except now we actually have content in both of these sections. So in the head section, this is on the main branch, right? So on the main branch, Bob already merged his things. So you have the message he wrote. And then on the my branch, here's the message I wrote. And they're overlapping because they're in the same line. And so as like the person who's merging it, I need to basically decide, okay, whose do I get rid of? um, and so for this one, Bob's isn't that useful. But actually, let's say we're gonna keep both, right? So actually, what you can do is you can literally just get rid of both of these, and now this is the commit you're making, right? So now it's essentially like you're making a commit, because all the merge thing does is it'll write all the changes, and then if there's a conflict, it'll just show you where it is. So now git status. Okay, it does the same thing. So I can git add text.txt, and now it's happy. And it says all conflicts fixed, but you are still merging. So it actually tells you to, it reminds you that like, hey, you're still in the middle of a merge. So if you do git commit, now it'll give you a default message. Merge branch as description, blah, 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 blah. Yeah, here we go. It looks like you may be committing a merge. And then if it's wrong, you can do certain things. But anyways, it's good. So we save it. Now we do Git Log. And so now notice fast forward. Okay, so I think this is what fast forwarding does, right? So fast forwarding, it will actually put Bob's commit on because it doesn't actually need to quote unquote merge anything. But for my branch, right? Since it had a conflict, now we actually have to merge it together, and so it'll create a merge commit. And notice how now that we've merged things, we can actually see, or since we're ahead of both of them, right? We can actually see the other branches, and that's how they're like behind master now, because we've merged changes in. And so normally branches are like very short-term usage, right? So we can just delete them when we're done. And actually that's what I'm going to do with -d. So that will delete the branch. Let's say delete branch. Exodus stuff. So yeah, that's how you use branches locally. And sometimes you do want to use branches locally if you like, oops, if you want to like make a change, but you don't want to like actually commit onto the master, just in case you want to get rid of it. Because you can do the revert thing, but it's much easier to just delete a branch and say, okay, scrap the idea. Let's try something else, right? However, most of the time, you're going to be working with other people. And so the question is like, how do you do that? Well, remote repositories. And so this is kind of where GitHub comes in. And so thinking about everything that I've already talked about, how every repository will save a history, right? What does Git do? So Git will, um, so as I mentioned earlier, Git is a distributed version control system. And so imagine if me and Bob were working on different computers, right? Um, so we want to have what quote unquote master uh, repository, right? It's kind of the same thing as branching. So let's say Bob has, or sorry, let's say we have a remote repository somewhere. Well, that place, one of those places is GitHub itself. And so GitHub is actually a really nice remote repository because it has a ton of support, it's free, and you have a ton of people pushing things there all the time. And so um, what Git does is it will essentially store a copy of your files and your file history. Um, and so by having that there, right, if you remember our branches, um, you can you can track or you can essentially say we have this remote repository in GitHub, and then you can make a copy of it. And I'll show you the commands. I think the next slides are commands. You can make a copy of that repository, and then when you finish making changes locally on your computer, you can push those changes to that remote repository. Then everyone else who's working on it can pull those changes, and then they can build on top of that. So here's more commands working with remote repository. So git clone, right? So this will actually create, or it'll actually create a copy of like everything that's stored. Well, I guess for this example, we're using GitHub. So we do git clone and then github.com/ and then repository name. Um, and so this will create a local copy of everything. And the important part is the history is the exact same, right? So it'll have the same commit IDs. And so when you want to go back and take your changes and merge it with what's in GitHub, it'll look through the commits and say, okay, these are all the same. So I don't have to worry about that, right? So then what if someone else makes a change and you already have the repository, so you don't need to git clone again. So what if you want to like pull their changes? Well, that's where git pull comes in. So it will basically it'll do two things, right? So it'll do a git fetch, which will fetch all of the data. So like it'll take all of the remote branches, and it'll pull in the data from GitHub, and then it will do a git merge. And so when you do git pull, it's pretty similar to a merge, where if you have conflicts, it'll tell you, and then you can fix those. Um, but yeah, git pull is when you want to pull in changes that other people have made, and then git push is when you have made changes and you want to update that remote repository on GitHub with those changes. And so that's what git push is used for. And then finally, I guess it's just a fancy thing I added at the end. So instead of merging, you can also rebase, which I doubt I have time to explain now. Um, but it will take all those changes. So when I made a merge thing, um, it creates a merge commit. And some people don't like that because it makes it messy. And so the idea of rebasing is you take all of the previous commits that have happened on the different branches and it'll like recommit them onto master. And so it does this recursive method of just adding the changes and like physically changing the master files, um, which is helpful in some cases, if you want it to be clean. Of course, if you want to like, okay, so when you push to GitHub, um, it like merges it automatically, I think, is how it works. And you can resolve it in GitHub too. But yeah, there's a ton more to learn about GitHub. And if you ever want to like look into it, um, or sorry, not GitHub, Git. Git, the Git website itself actually has a ton of really good tutorials. And of course, you can read through the man pages, though that's probably not that fun. And of course, there are a ton of resources online. So if you don't know how to do something, just Google it. Besides that, yeah, that's pretty much it. Um, Best way to learn, obviously, is to practice. You can look through like the commands and stuff. You can read all these guides, but the best way to learn is just make a repository, play around with it, see how badly you can mess it up, and if you can fix it. But yeah, that's pretty much it. So thanks for coming. If anyone has any questions, you can ask or you can leave. Yeah.